about how hurricanes form, and we know a little bit about the structure of a hurricane. Why do we evacuate them to begin with? Why are they so dangerous? What is it about a hurricane that makes it so dangerous? How do we evacuate? How do we know about them? How do meteorologists even tell us about them? What's the whole thing with names? That's what we're going to talk about in this lecture. So, a lot of stuff. It's going to go really fast, so hold on. First off, what are the hazards caused by hurricanes? Well, hurricanes are deep areas of low pressure with a lot of moisture and very high winds. As a result, the winds can become so high, especially in major hurricanes, that you can get structural damage to your home. Not just tiles being ripped off or a window being broken, but you can actually have full structural failure. You can have your roof ripped off, and so on. And so wind damage is oftentimes a hazard caused by hurricanes. On the other hand, even if the winds aren't very strong, even in some tropical storms, if the storm doesn't move fast enough, you've got a very slow-moving storm that's just ripe with moisture, meaning that there's a lot of rain in it. That rain, if it parks over one location, you can see cities that get 10, 15, 20 inches of rain in just a day or two. An example of this was Tropical Storm Allison, which formed in the early 2000s. It moved over Houston, Texas, and it wasn't a very intense storm. It wasn't a hurricane, wasn't a Category 5 major ripping roofs off of houses, but the Houston area got over 38 inches of rain in a 6-day time period. This storm just stayed in place, dumped over 38 inches of rain. And I don't care where you live, 38 inches of rain in such a short period of time is going to cause some massive flooding. And the flooding in the Houston area was so intense that it killed over 40 people. Not only that, but the name Allison became so infamous with people in Houston that they never named a storm that again. And we'll talk more about that in a few minutes. However, the deadliest element, even though the winds can be high and the rains can be heavy, the deadliest element caused by hurricanes is what's called storm surge. Basically what happens is, as the center of low pressure approaches, and you have these cyclonic winds blowing around in the storm, that actually causes water to bunch up in a gigantic dome. And this forces water levels to rise. It's almost like a permanent high tide, in a way. And these tides can become so high, these water levels can be so high, that areas right near the coast can be flooded. And not only can they be flooded, but then you also have higher and stronger waves. So not only are they being flooded by ocean water, but then they have these huge waves crashing in and damaging their homes. As a result, storm surge poses the greatest threat in hurricanes. You can bunker down from wind damage. Flooding is very, very damaging, but if it's not sudden, it's not going to be too bad. But in the case of storm surge, this can happen very rapidly, very suddenly, and it can be very destructive. And so storm surge is often billed as the deadliest element of tropical systems. Now, you would think, okay, well, storm surge only affects areas right on the coast. Well, think about Florida. Florida has a very low elevation. Much of the areas near Florida are barely above sea level. As a result, if you have a really high storm surge, the ocean can move inland by miles, and all those waves are going to move inland by miles. So, storm surge can actually be a widespread issue. The last hazard that hurricanes can cause are tornadoes. And the reason why these happen is you have land and high winds blowing over that land. That creates a substantial amount of vertical shear. This causes tornadoes. So you can get a lot of land spouts that develop and a lot of vertical shear that can create mesocyclones and can also create supercells, which can create tornadoes. Here's an image just showing some of the wind damage from hurricanes. This first one is a flimsy gas canopy. However, roofs have also been ripped off, and houses have actually been flattened from some hurricanes. Hurricane Andrew is an example of that. Many neighborhoods were flattened because of that storm. Here's an image of flooding in the Houston area after Tropical Storm Allison. Here are some tornadoes that were caused by hurricanes, including just normal tropical storms. And then here's storm surge. As I mentioned, storm surge is the deadliest element. And the reason why it's the deadliest element is because it takes the water level, it takes the sea level, and it pushes it up. This is in addition to the waves. So not only do you have a higher sea level, you then get those stronger waves, and it's those stronger waves that are then going to pound away at your house. That's why storm surge is so deadly. Now, because hurricanes and tropical storms pose so many hazards, we want to warn people about them. We want to let people know, one, that a storm's coming, two, how bad it's going to be, and three, should they evacuate or not. And we want to make sure that we give them excellent information so that we don't incite panic, but that we do let people know, hey, this is what's happening. Now, every government is responsible for issuing their own advisories. Every government. So any advisories for Mexico are issued by the Mexican government. Any advisories for Cuba are issued by the Cuban government. Any advisories for Canada are issued by the Canadian government. And similarly, here in America, any advisories are issued by the federal government. And the agency that we have here in the United States that issues these watches and warnings is called the National Hurricane Center. And so it's the National Hurricane Center that's been given the authority to issue these watches and warnings. Now that's a good thing, because these are also the same people that are tracking and forecasting these storm systems. So if we needed somebody else in the government, such as a senator or such as the president himself or herself, to ever issue one of these advisories, it would have to go up a chain of command, and so it's a good thing that we don't have that. Instead, it's the National Hurricane Center. They're given the authority to issue these advisories. Now, what kind of advisories can they issue? Well, the first thing is they need to know, is this going to be for a tropical storm or a hurricane? The amount of preparation you're going to need to take really depends on that question, that answer. If it's a tropical storm, again, it might just be a bunker down. Even if you are near the ocean, just bunker down. You're going to be okay. Just make sure you have food and water. Might be without power for a few days. If it's a hurricane, then we need to know, okay, well, areas need to start planning evacuations, and this is a more serious issue. So watches and warnings, these advisories, are issued for both tropical storms and hurricanes. If a storm is possible in your area, if there's a good potential that a storm may affect your area, a watch is issued. And a watch basically means, hey, this very possibly might happen, keep an eye out for it. On the other hand, if we expect it to happen, if the confidence is really high that, hey, this is going to happen, we can issue what's called a warning. And a warning is more imminent. This means that the storm is expected to affect your area in the next 24 hours. So a watch gives you 48 hours of alert, and it alerts you to potential effects, a warning gives you 24 hours of alert, and at that point, we're pretty confident that your area is going to be affected. This is a map designed by the National Weather Service for Tropical Storm Hermine, 2010. And this was a storm that formed off the Gulf of Mexico, and it looks like it's going to hit almost right on the US-Mexico border. As you can see, the National Hurricane Center has actually issued warnings up and down the coastline for tropical storm conditions, and the Mexican government did the same. And there's usually a lot of continuity and a lot of collaboration between governments in the case of a hurricane. You want to help each other out. Now, the other thing you may notice here is this blue line represents tropical storm conditions, and that a tropical storm is expected to affect these areas in the next 24 hours. However, superimposed in a small area of this is a pink highlight. That pink highlight actually indicates a hurricane watch. What this means is that we expect a tropical storm to hit this region. However, the storm is still out over the ocean. It's in favorable conditions, so low wind shear, warm waters, moist air. It could intensify to a hurricane. And if it does intensify to a hurricane, we want to alert you that, hey, that's a possibility. So this may turn into a hurricane. One other thing I'm going to show you really quickly about this is you notice this envelope here. And they've changed these slightly since, but it's almost the same thing. This envelope here, this white highlighted area, shows where the center of the storm may potentially go. This middle line represents where they think it's going to go, but these sides represent potential error. And so this storm could hit anywhere in this area. The center of the storm can hit anywhere in this area. Now, one of the reasons why, if you notice, this tropical storm warning is expanded greater than the highlighted white area, well, the reason why that is because this just shows you where the center might go. But remember, storms aren't just a center. A hurricane's more than just an eye. This storm system may actually be, and I'll use a line here to show this storm may actually be much larger in size. And so even though this area down here might not get the center of the storm, they may still get tropical storm conditions. Same for up here. This area up here might still get tropical storm conditions. So there's a lot that goes into these forecasts. And basically what I would tell you is if you're in a location that has been issued a watch or a warning, definitely take that seriously. Don't think, oh, well, the cone, this envelope shows that, the storm's not going to hit us. No, that just means the center of the storm's not going to hit you. But you can still get good effects from it. You can still get major effects from it. So the other thing that meteorologists do to help people prepare for these storms is they give them names. The reason why they give them names is because more than one storm can be present at a time. And so if you have 3 hurricanes out in the Atlantic, people want to know which hurricane you're forecasting for, which hurricane you're talking about, which hurricane is going to hit your area. You want to be able to distinguish one hurricane from another. And so what meteorologists decided to do is, rather than giving them all confusing names based on their location or anything like that, they gave them names, just a simple name like Eric or Sandy or Katrina or so on. And then whenever that hurricane is assigned a name, or whenever that storm is assigned a name, it keeps that name for the rest of its life. If it crosses over into another hemisphere, it keeps the name. If it transitions from the Atlantic to the Pacific, it keeps that name. That's actually happened before. If it does anything like that, it keeps the name. As long as that circulation maintains intact, it keeps the name. And these names have been, one, internationally agreed upon, and that's a good thing because if we're calling the storm Katrina and Mexico was calling it Sandy and Cuba's calling it Thomas, then there could be some confusion. So we internationally agree upon these names. The names are given by the forecasting office that's tracking the storm. All of the governments in the Atlantic Ocean Basin have all given that power over to the National Hurricane Center. Yay. In the Central Pacific, there's a hurricane center based in Honolulu, Hawaii, called the Central Pacific Hurricane Center. And then in the Western Pacific, there's a center called the Joint Typhoon Warning Center, and that's a combination of the U.S. Navy and the Japanese Meteorological Agency. And there's a little bit more to it than that. But these governing bodies name the storms. And the names aren't names that are drawn out of a hat or names that are come up with on the fly. Rather, they're actually taken from a list. And that list gives names usually from A to Z. In the Atlantic, they usually don't go all the way down to Z because some letters like Q, X, Y, and Z are hard to come up with names. So they usually don't go down to those, and especially in the Atlantic where most hurricane seasons don't produce this many storms. In the Eastern Pacific, they actually do go all the way down to Z. Now, what actually happens is, once a list is used, it's not just thrown away and a whole new list of names is brought up. That would mean a lot of extra work. And just the same way that as a teacher, if I find an assignment that works well and it gets the job done, rather than reinventing the wheel for the next semester or the next quarter, I'm just going to reuse the assignment. Well, the National Hurricane Center reuses the list. The National Hurricane Center reuses the list. So they'll take a list that was previously used, and 6 years later, they use it again. So, for example, this year we had a tropical storm named Arlene. Well, 6 years from now, in 2023, let's see, more like 2022, I'm sorry. In 2022, we're actually going to use Arlene again. Same thing with Brett, and so on. We reuse the names. Now, I know what people think when they hear that, though. Wait a second, does that mean Katrina's going to be used again? Does that mean that Andrew's going to be used again? I don't see those names on this list. If you pause and you look, you don't see them on here. Well, here's why. I mentioned a few slides ago that Tropical Storm Allison, which formed and hit the Houston region, that name was retired. The reason why it was retired is because that name became infamous. That storm was so intense and had so much loss of life, so much death, so much destruction that using that name in the future could confuse people. Using that name in the future would not be a good idea. So what they do in that situation is they retire the name. So rather than coming up with a whole new list, they only come up with new names when a storm was particularly bad. And that name will always be associated with that storm. Let me give you an example of this. This is Tropical Storm Katrina, 1999. Tropical Storm Katrina was a weak tropical storm. It formed, hit land, and died very quickly. It wasn't even around for a full day. This storm really, people aren't going to remember it. It didn't really cause any deaths, no real destruction. It was just a rainy day for the people that were living down here. Just a rainy day. So Katrina was reused again. In 2005, it was assigned to a tropical storm that formed off the coast of Florida and eventually intensified into the most damaging hurricane in United States history. And this hurricane was so damaging, not necessarily because of how strong it was, but because of where it hit. Hurricane Katrina hit the New Orleans area. As I mentioned earlier when I talked about storm surge is really bad for low-lying areas close to sea level. Most of New Orleans is actually below sea level. And so Hurricane Katrina caused substantial damage to the city, and it killed over 1,700 people, almost entirely in New Orleans. Now, with that said, Hurricane Katrina was an intense storm. At its maximum, it had wind speeds of 175 miles per hour near the center. So right here in this eye wall, wind speeds of 175 miles per hour. That's the equivalent of an EF4 tornado. So that is extremely intense. Extremely intense, can cause tremendous damage. However, as it hit land, it underwent something called an eye wall replacement cycle. We still don't understand why this happens, but as hurricanes intensify, at certain times, their eye wall will collapse and a new eye will develop. During that time, the center of the storm becomes disorganized and the storm weakens slightly. And then once the new eye is created, it strengthens again. Well, that eye wall replacement cycle happened right before landfall. And so the storm had weakened before it hit land. However, because of where it hit, it went down in history as the deadliest storm in modern U.S. history, and at least in the last 100 years. We haven't had too many storms this bad. The deadliest storm we ever experienced was a storm that hit a town near Houston called Galveston. And that storm came without warning, but that was in 1900. But definitely in modern U.S. history, this was the deadliest storm. And just to give you a little comparison, there were some other notable storms. All of these storms eventually had their names retired. All of them hit land in the United States. All of them caused tremendous damage, and all of them caused substantial deaths. However, if you look at some of these storms, and some of these storms are very historical storms, Ivan, Charlie, Andrew, and Hugo, if you look up, I guarantee you all four of these will have their own Wikipedia page. They'll probably have tons of articles written on them. You could do a lot of research on each one of these storms. And if you add up all the death and destruction caused by them, they still paled in comparison to Katrina. And the reason why was because Katrina hit the worst possible place. It hit New Orleans. Now, that's it for this lecture. So, in this lecture, we talked a little bit about the hazards caused by hurricanes. So, those hazards were high winds, heavy rain, storm surge, flooding, and tornadoes. Then we talked about hurricane names. Hurricane names are assigned from a list, and that list is reused every 6 years. If the storm is particularly damaging, that name is retired and a new name is created. So that's it for now. The next lecture, we're going to talk just a little bit about superstorms and a little bit about other forms of extreme weather. Until then, I'm Terrence Mullins. Thank you for watching.